right, so your geometric sequence formula, you still have similar notations here. This is still referring to the nth term. This is still the first term. And you'll see there's an R. So R is basically like D. It's the thing that you're, that's telling you the pattern. We call it the common ratio, which is why it's an R. So it's the number that you're multiplying by to get to the next term. Okay. Your n minus 1, again, still the same idea. Now, you have to be able to recognize a geometric sequence, and sometimes it's really obvious and sometimes maybe it's not. And when you kind of put geometric and arithmetic in the same problem, so like on your test, for example, they're all going to be blended in. It's not going to say, this is an arithmetic sequence. It's going to say, this is a sequence, figure it out. And so arithmetic sequence, you can just like subtract, like 10 minus 30, and if that's the same as, this minus this, then you know it's arithmetic. With geometric, you would divide. So to see what R is, or to test to see if it's a geometric sequence, you would take some term and divide by its previous term, and that would give you R. And then simplify if possible. So in this case, I get a third. That's how you find R. So you take some term and divide by its previous term. The immediate previous, not like some random previous term. If you do it with these two, you'll get the same answer, it's just harder. So like, you can take 10 thirds and divide by 10. You'd keep, change, flip, and you'd still get a third. So you can see that it is geometric. You could have a sequence that's neither geometric nor arithmetic. Okay, it could just be like random. But that does not apply. We have a geometric sequence here. An explicit formula is what we just came up with the checkerboard problem. It's a formula that will work for any n. A recursive formula, which is on your vocab. A recursive formula, you need the previous term to get to the next term. So, have you seen this before? No?
Oh, that's the, not the Fibonacci.
Yeah.
Oh, it is?
It's
Okay.
the Fibonacci sequence.
Okay, cool.
In the Fibonacci sequence, you have to know the term that came before it to get to the next term. So like 2 is the sum of 1 and 1. 3 is the sum of 2 and 1. 5 is the sum of 2 and 3.
Oh, yeah, totally.
And so there's only one way you can know the next term, and it's by knowing the previous term. This kind of sucks, because if I want the 500th term, it's going to take a really long time. Like Pascal's triangle, that's how we learned Pascal's triangle. We kind of just added previous terms. Now there is a way to find the numbers in Pascal's triangle without doing that. You'll learn that in pre-calc. But that's an example of a recursive pattern. When you know the previous term, that gives you the next term. An explicit formula, you don't have to know the previous term to know the next term, or you don't have to know the previous term to know the 10th term or the 100th term. You can use that formula to find any term you want. So all we're going to do is plug in our information into this. So we know the first term in our sequence is 30. So a sub 1 is 30. The ratio is 1/3. That's what we're going to put right here. And then n minus 1 and a sub n go there. That is a formula that we could use to find any term in our sequence. And we would find those terms by simply plugging in some value for n. So just like a regular little...
Oh, and when you find the 10th term, then you would put 10
Wait,
as
did
n.
you always put the second term over the first term to find the ratio?
Or the third over the second, or the fourth over the third. Just some term divided by its
The one in
previous
front.
term.
Okay.
So if we want to find the 10th term, we're just going to plug in 10 for n. Now, in some situations, this is kind of hard to simplify. Like the numbers are really big. We're going to do this. We're going to attempt to do this without a calculator. because I want you to know how to simplify without a calculator. When you take something and you multiply by something to the power, we still use PEMDAS, so you have to do the exponent before you multiply. Another way of writing this would be 1 over 3 to the 9th, because 1 to the 9th is 1, 3 to the 9th is, I don't know. And then another way of writing 30 times 1 over 3 to the 9th would be 10 times 3 over 3 to the 9th.
Does it matter which way we do?
It's easier to show. If this is 1 3 and there's 9 3s on the bottom, we can cancel a 3
This is just.
and get 10 over 3 to the 8th. And then if we can figure out what 3 to the 8th is, then we can just do 10 over that. And so,
Right over.
Oh my god.
we already know, like, I don't know, do you know, like, 3 to the 4th?
No.
I don't know, 3 to the 4th?
9 times 9 was 81.
So another 3 to the 4th would be another?
81.
Okay, then we just multiply 81 times 81. Oh, Griffin. Oh, there we go. No?
Yes, and then you have to divide
I hope I
10
multiplied
then.
that right. And so then you just do 10 over that.
That's 16, that's 5, yeah, that's right.
Ta-da!
That's just disgusting.
Ew. Yeah, but like you see the tricks.
I just would never have been able to do that without you.
I know, but now you know, and now you can do it on your
I
own.
don't think I can.
I'm just gonna real quick check that because I'm sick and I've made mistakes before.
I've made mistakes.
I've made so many. No, I'm good. I still got it. But I don't because I already made like 3 mistakes today, so.
A1 is just 1. Okay.
A1
And then
sauce.
Yes,
5
okay, so
divided
try
by
the U-track.
5.
Hold on.
Numerator
U-track.
and the denominator.
But don't worry, guys. I
So
have
we
some.
know the numerator is 4, and the denominator, if you don't want to multiply, you don't have to look, you just make a tree.
That's
And
what
then you
I
have
did.
3s and 5s, and that's 15.
I did it differently in more an annoying way, but I did it, so.
And that's what your answer is.
That is gross.
Now, another thing with geometric sequences that you don't have to worry about for this question because you're bouncing and they're centimeters. When you're talking about a sequence, your sequence could have an r of a positive number, but it could also have a negative number. So we didn't really do that many examples up there. But you could have a geometric sequence where r is negative, so something like 2, negative 4, 8, negative 16, and so on. So when you're just finding the missing term, it could be 4/15, but it could also be negative 4/15. So we're gonna put a plus or minus here in this situation that maybe r is negative.
Example 4 is so easy.
Now sometimes they'll tell you if r is positive or if r is negative. So in this question, if r is positive, then the second term would have been 4/15. But if r is negative, the second term would have been negative 4/15. Because it would have gone negative if r was negative 2/3. And so if they don't tell you if r is positive or r is negative, you technically have 2 options. We didn't have 2 options here because you can't have negative 70 centimeters. That doesn't make sense. You don't have to worry about it there. And then in the previous questions, we could tell that r was positive for most of those questions. We didn't have to worry about it there either. Let's look at this one. So for this one, there's more missing terms. We can find this one and then use the pattern to find the previous terms. So if this is 4 and this is 16, I can find this guy by square rooting 4 times 16,
Okay, why did I get a number in thousands?
which is the square root of 4 and the square root of 16. This is 2, this is 4, this is 8.
And then you're just like, it's multiplied by 2, so you divide 4 by 2 and divide
Right.
2 by 2.
So then you can observe the pattern. It's clearly times 2. And we want to go back in the sequence. So this would be 2 and this would be 1.
The U-try doesn't make sense because the number is enormous.
Hold on. Now, this could be 8 but it could also be -8. So we technically have like 2 options
But
here.
don't you like know because like you can't go from 4 to -8 to 16.
It can.
Oh god.
Excuse me.
So
Because if it's a -2,
if this is positive, 1 could be negative, and then 8 would be negative.
So we just say
They would
plus or
alternate.
minus 8.
Yeah, and plus or minus 2. Or you could put, you could put both, like what we had there and what I have down there. So every other term is affected if R is positive or if R is negative, and if they don't tell you, you have options.
So like I started the other problem and then realized that I don't want to do that much division.
Positive 108 because it's the middle of 2 positive numbers. These,
It's debatable.
not sure, yeah, debatable. So you can do it again to find, I would pick the 2 smaller numbers,
That's what I
the
did.
middle of 108 and 12. So 108
12 and 9.
is 9 and 12.
And then-
We have a group of 12s.
Oh, I did it a long way, but
Group
like
of
I worked.
3s, yeah, it's fine. And this is 36. Could be positive 36, could be negative 36.
And then you can just tell it's divided by 3, and then you just multiply 1 away by 3.
So once you find the ratio, this is a ratio of 1/3.
You need us to write a ratio.
In some situations you do, that's why I'm putting it there. It didn't
Oh
ask
wait,
for
so
it
I
here.
can't put like divided by 3. It has to be like the fraction.
That's why that's kind of why I wanted to point it out. So
Okay.
a ratio is something you multiply to get to the next term. So you, even though you're thinking about it divided by 3, it's technically multiplying by 1/3. And we're not sure if it's positive or negative. So if asked, your ratio is either positive 1/3 or negative 1/3, but we're not really sure. And then we can just multiply this by 3 and get
3 times 3.
324,
Yeah,
9,
that's right.
9 times 4 is what?
possibly positive or negative.
Cool, I did it. Kathleen, was
Mhm.
the Spanish test? It's just on vocab, right?
It's not hard.